What do you know about thunderstorms?
I know that one of the clouds is called a cumulonimbus, and it's huge, and that's about it.
I know that I'm afraid of them if they're too severe.
It's like electricity in a cloud. I've heard that it's like dust particles like clash together and like friction sets up like a chain reaction or something like that. I know lightning makes ozone, and I know they involve a lot of energy.
Is this for real?
Yeah.
Is that an actual? Oh, okay.
Thunderstorms are big.
Ooh, thunderstorms are they're exciting things. I know that it's the clouds get a lot of water and they end up having to dump them off, and when the clouds like rub together, I think that's what makes the lightning, something like that. But obviously, I'd like to know more.
Here's Jeri with the inside scoop. Heads up.
Thanks, Katie. Thanks, Maddie. These are all good questions, and I think I can answer some of them. So, air cools as it rises. Then the water vapor condenses and forms cumulus clouds. When the condensation occurs, heat is released, and it helps the thunderstorm grow. At some point, the water droplets inside the cloud become so heavy that they fall to the ground. It rains. But this is stuff we learned in elementary school. What we need to figure out is what is actually going on inside of the storm.
The sky is full of electrical charge. On a normal day, the positive and negative charges are evenly spaced throughout the sky. Inside a thunderstorm, there are hailstones and ice crystals. The ice crystals have a positive charge and the hailstones have a negative charge. The positive charge moves to the top of the thunderstorm and the negative charge moves to the bottom of the thunderstorm. The negative charge at the bottom of the thunderstorm wants to meet up with the positive charge of the Earth's surface. The positive charge of the Earth's surface and the negative charge of the thunderstorm meeting up is lightning.
But lightning is easy to detect. What we want to know is how the meteorologists find the storm itself. We can see thunderstorms with a variety of tools. Most of the areas on Earth can be seen by weather satellites. Satellites take pictures of Earth at regular intervals from space, telling us where clouds are located. Meteorologists watch these pictures over time to watch for rapidly growing clouds, a clue to possible thunderstorms. Satellites can also tell us the temperature of the clouds. Clouds with cold tops are usually very high up in the atmosphere and could mean the cloud is tall enough to be a thunderstorm. Meteorologists also track how these clouds move to see what areas will be affected by the storm. Doppler Radar sends out electromagnetic wave fields that can be reflected back to the radar by things in the air like precipitation. The amount of energy that is reflected back can tell us how heavy the rain might be, or tell us if there is hail. Doppler radar can also show us how the wind is blowing near or inside the storm.
Okay, so now we know how storms are detected, but what is the reason for the calm before the storm? So what happens is, in a storm, you have warm, moist air down here, and there's a low pressure vacuum that's created. And so that low pressure vacuum is then gonna suck the air, warm, moist air up into the cloud. And it's my cloud. And the updrafts of that are gonna then pull that air up to the top, and eventually it's gonna send it over the sides of the cloud back out. And then the same vacuum that sucked the air into the cloud is then gonna pull that air down. And as it pulls it down, it's gonna turn into warm, dry air, and that's gonna stabilize the region around the cloud and create the calm before the storm.
Following that calm comes the length of the storms varies depending on the size and the type of the storm. Many storms can take up to 30 minutes and be at least 15 miles big. We've talked about a lot today. We've talked about the calm before the storm, what determines the length of storms, how thunderstorms are detected, how thunderstorms start, and why some storms have lightning and others don't.
Thunderstorms can sometimes be dangerous or scary, but in areas like ours, they're definitely necessary, especially for all the farmers.
As time goes on, technology will continue to increase and we will learn even more about thunderstorms.